So I welcome you all in this another lecture of computer system architecture. And in this video lecture, I am going to explain you about the number systems, right? So there can be various number systems, and it depends on the what is the base of that system. The base represents the numbers are in that system, right? So for the binary we have base 2, for the decimal we have base 10, for the octal we have base 8, and for the hexadecimal we have the base 16. This base represents the number, the counting of the numbers that are in these number systems, right? So for binary we have two numbers because the base is 2, so we have two numbers, 0 and 1. For the decimal we have 10 numbers, 0 to 9. So 0, 1, 2, 3 up to 9, right? And we are familiar with this decimal number because from our childhood we have learned the decimal numbers, all the addition, multiplication, subtraction, division, and all the operations we have performed or we have done using this base, which is decimal number system, which has the base 10. Base is also known as radix, right? So do remember that the base is radix. Okay, so we have the octal numbers, we have that contain the 8 numbers, right, which starts from the 0 to 7, right? 0, 1, 2 till 7. So right, then we have the hexadecimal number, and it has the it has the 16 numbers, like 0, 1, 2 and till 9. It has the same representation as in decimal numbers, but after 9 it has 10 for A, right, 11 for B, 12 for C, 13 for D, 14 for E, 15 for F. Okay, so these number systems we have to study, right? And we will see that how we can convert the binary to decimal and decimal to binary, and vice versa in any of the systems, because they ask you about that. They give you some numbers and they say that, like 101, convert it to into the decimal, right? Convert it into the decimal. Or they ask you like A 72, which is your hexadecimal number, and they ask you to convert into the decimal number. So they can ask you any base conversion on any conversion into any of the radix, right? So this is your so in the upcoming lectures on these number systems conversions, we will explain you these number conversions in uh, in step by step, and with all the fraction parts in it, because they are not going to ask you this simple questions to convert these bases, but they can also ask you like this, that convert this number 1 0 0 with some fraction part, like 1 1, right? So this is your fraction, right? So convert this number into decimal or octal or whatever they will ask. So convert it into the decimal. So how to write these numbers and how to convert these numbers, this is your uh, is uh, is challenging, because that we have not learned to convert this fraction part into the decimal, or the convert the decimal fraction part of the decimal numbers into the binary representations. So let me explain you in this class about the about some number conversions like with fraction parts, because you already know about the how to convert this binary to decimal and decimal to binary. So I will explain you the decimal to binary conversion with fraction part and without fraction part. Okay, so let me introduce the decimal to binary with fraction part and without fraction part, right? So here you can use, we will take this as, right? So let me rub this, right, this part only, and yeah, okay, it's almost done. Now by taking some examples, like first I will take some very basic examples, right? That convert 15, right? This is your decimal number and it is base is 10, so that's why we write base 10 here, right? So convert this into binary. So what we are doing, we are converting the decimal numbers to binary representation. So decimal to binary converge, right? Decimal to binary. So how we convert the decimal to binary? We know that we have to divide this decimal number by 2, because because when we are converting this base to another base, so in which base we are converting, we divide the number with that base. So here we have the decimal number and we are converting to the binary number. So what we have to do to convert into binary, we have to divide it by 2. So divided by 2, right? So you write in this, you represent this in this fashion and divide this by 2. So 2 divided, divide 15 by 2 at 2 7s are 14 and remainder is 1. So write remainder is 6, right? So represent this in this way. So 2 3s are 6 and 1 here, right? Then we have 2 and 2 1s are 2, right? And 1 is your remainder. So in this way you will see, right? So how to use this number and how to write this number. So to write this number, what we have to do, we have to consider from the down to up, right? Although in this case this is a palindrome number, because from this way, from up to down and down to up, it's the same. But what you have to do, you have to take the numbers from this way, right? From up, from down to up, right? So we have this 1 1 1 and 1. So this is your binary conversion of the 15 number. Okay, I think now you have understood it, and if you have any questions regarding this or any type of number you want to convert, you convert into the same fashion. And if you still don't know, and if you have any doubts, please let me know, right? And then let me modify this number with some fraction part, right? So we have this fraction part 15 point, like 15.15, right? 15.15. So what to do in that case? So we have convert 15 to this representation, but what we have to do, we have to convert this 0.5. We have to convert this 0.5 to the binary. So in that case, we have to we will not divide this number by 2, but when we have this fraction part, we will multiply with this base, which is 2, right? So we will multiply this 15 to, right? So when we will multiply this, it will be 15 to the 30, right? So we will write 30. So the decimal or the fraction or the decimal point is point where the two places, so it will be 0.30, and here we will write the 0, right? And then we will write 0.30. So this number will be there, right? Again we will multiply, right? So we will multiply it, because this question will come in your mind. So sir, how many times we have to multiply, or till what point we have to multiply? So we have to multiply this number till the time it becomes 0 0 here with the fraction part, right? So here 0.60, right? So again here it will be 0, right? And then 0.60. So again this number will be multiplied by 2. So multiply by 2, and then it will become like 120, because 60 is multiply 60 by 2, it gives us 1 2 0. So the fraction will be here, right? Or the decimal point, whatever you say, right? So again it's not 0 0 with the, because we have to multiply until this fraction part, this value becomes 0 0. Okay, so until that point we have to calculate, or we have to multiply by it. So but only the fraction part, right? So again let me write here, right? So we have fraction part is 0.20. We will not take 120, right? We will take this fraction part only. Please do remember. So when we are converting the fraction part to the binary numbers, we will consider only the fraction parts. Okay. So 0.20 multiplied by 2, it becomes 0.40, right? 0.40. So you have to write 40 here. and then here we have this point, and then this is 0, right? And then when you write when you multiply 0.40 by 2, it will become what? It will become 0.80. So 0.80, right? 80, right? And then again when you multiply this 80 by 2, it will become 160, right? 160. So we will write 1.66 and 0. So if you look at closely, it come out with a pattern. What pattern it will be? It will be like when we have 0.60, so when we multiply this 0.60 by 2, right, it will become 1.20. So this case, right, 1.20. So it will be like, because it gives you 120, but because with the fraction part we have to write this 1.20, right? And then again for the 0.20 we have this. So it will be like a infinite loop, right? So how to write this representation? So in that case, what you have to do, let me write it here. Okay, let me write it here. So how to represent it, how to use it? So you have to take the decimal point here, because 15 we have already converted, and this 15 is converted here. So how to write here? In that case, that was the without fraction part. We are taking these numbers from down to up, but here we will write this number as up to down, right? So in that way, right? In that way. So because we start with this point, so we will write 0, then this 0, then this 1, right? Then we have this 0, then we have this 0, then we have 1, right? Then we have 1. Okay. Now see this, because we can see that this pattern is like when we have this 0 0, then again we have after this, right, after this step we got again 60 here, right? We got 60 here. So we have this 0 1 and 0 0, 0 1 0 0, right? And then from this point after 0 0 we have this 1 1 0 0 1, then we have 1, and then again 20 will become 40, and then 40 will become 80, then it will become 60. So it will be like 1 0 0 1, 1 0 0 1. So this pattern will follow. So again we will have the 1 0 0 1, 1 0 0 1. So the repetition of these 4 bits, 1 0 0 1, right? 1001. Again it will be 1001, because when we multiply 0.20 to 2, it will be 0.40. So again this pattern, this 4-bit pattern will be repeating. So how we will write this fraction part? We will write this fraction part as that this will be like this, right? Because this is repeating. Or you can write it as dot dot, right? Means it is continue. So this pattern will be continue. So this is the way that you will represent your fraction part in binary numbers, right? So in the upcoming video we will see that how we will convert the uh, binary to decimal with fraction parts, right? So I hope this conversion is very much clear to you, and if you have any doubt regarding this, please let me know. So thank you very much.